Manufactured substances industry, ammonia. So first, we discuss the process in producing ammonia in industry. The very first thing that you need to know is the name of the process. You always remember, okay? The process to produce ammonia is called the Haber process. What's the name of the process to produce sulfuric acid? Okay, any of you tell me? Contact process, that's correct, okay? And to produce ammonia is Haber process, okay? Haber is the name of a scientist. Unlike a contact process, Haber process, you only have one step. In contact process, we have 4 stages, right? Okay, we have 4 stages to produce sulfuric acid. But for Haber process, there's just one step or one stage. So each is much easier or simpler compared to contact process. Okay, now ammonia is a molecule that contains 1 nitrogen and 3 hydrogens. So to produce ammonia, we just need nitrogen and hydrogen. That's all. Nitrogen gas, okay, in gas react with hydrogens. Okay, the ratios of nitrogen and hydrogens in ammonia is 1 to 3, right? 1 nitrogens bond with 3 hydrogens. So therefore, the ratio that we use is also 1 to 3. Yeah? 1 nitrogen molecule react with 3 hydrogens molecule produces ammonia. Okay, produces ammonia. Okay, now what is this? This is called the heat of reactions. You're going to learn heat of reactions in Form 5. Okay, so for the time being, if you don't know what is this delta H, okay, it's okay. Yeah, because you are going to learn in Form 5. Okay, negative 92 kilojoule per mole. Okay, this shows that these reactions release heat. This is exothermic reaction and it releases heat. But anyway, you don't need to worry about this. Okay. Yeah, because in Form 5 you're going to learn this. So now in Form 4 you just need to know these equations of reactions. Now one important thing that you need to know is this reaction is also a reversible reactions. If you still remember, we discussed reversible reactions, right? Okay, from SO2 to SO3, yeah? Sulfur dioxide to sulfur trioxide is a reversible process. So for reversible process, nitrogen react with hydrogen to form ammonia, and ammonia at the same time, ammonia it will decompose to form nitrogen and hydrogens also. Okay, so these two can react to form this, and this also can decompose to form this. It's reversible. Okay, reversible. And for reversibles, as we discussed last week, for reversible process, then you need to consider, or you need to find the best condition, the optimum conditions to produce most product in the shortest times. If you still remember, we discussed that later. Okay, we discussed this last week, and we are going to discuss this later. The condition for these reactions to produce most product in the shortest time. Okay, now that's the first thing that you need to know about manufacturing ammonia. The name is called the Haber process, and this is the equation for the reactions. Nitrogens react with hydrogens to produce ammonia. Okay. Now, another important things for Haber process that you need to know is the sources of the raw material. The raw material is the hydrogens and nitrogens. Okay, and as I told you just now, we need large amount of nitrogens and hydrogens. So where do we get this large amount of hydrogens and nitrogens? Okay, for hydrogens, we get it from water. Water is H2O, right? Water is H2O, means that in a water molecule, H2O, there is 2 hydrogen atoms, right? Okay, so we can obtain hydrogens from water. The water is in gaseous state, steam, okay? So we heat steam or water together with Coke, okay, Coke. Now this Coke is not the Coca-Cola, okay? This Coke is carbon. Carbon is carbon. So we heat steam with these carbons, okay? Then you can get hydrogen gas. Or we heat the steam with natural gas, methane, okay? Methane gas. Then you can get hydrogens, okay? Now the equations for the reactions is not important here. Okay, the equations for the reaction is not important here. what you need to know is we obtain hydrogens from steam, either the reactions between steam and coke, okay, or the reactions between steam and methane. That's all, okay. This may be asked in exam, the sources of raw material, the sources of hydrogen and the sources of nitrogens, okay. Now for nitrogens, we obtain the nitrogen from the air. In the air, there are 76% of nitrogens, 76% of nitrogens, and then about 21% of oxygens, and then the other gas, and then we have the other gas like carbon dioxide and the inert gas. Okay, you see, we have large amount of nitrogens in the air. Okay, large amounts of nitrogen in the air. But the problem is, how do we separate these nitrogens from the other gases in the air? Okay, so what we do is we compress the air. When you compress the air in a very high pressure, the air will become liquid. You compress it, it will become liquid. We have liquid air. The air is the air around us. Okay, the air around us. We compress it to make it to become liquid. And inside this liquid, then we have this liquid nitrogens, liquid oxygens, liquid carbon dioxide, and we separate all these nitrogens, oxygen, carbon dioxide in a gas through a process called fractional distillations. Then we get nitrogens. Okay. Now how do we do this is not important here. Okay, so I'm not going to discuss with you how to do these fractional distillations. You just need to know that we get the nitrogen from the air, okay, and to separate this nitrogen from the other gases, we compress it to become liquid, and then we do fractional distillations to separate these nitrogens, liquids from the other gas. So hydrogens from steam, nitrogen from the air. That are the sources of raw materials in Haber process. Condition for this Haber process. As I told you just now, Haber process is a reversible process. Okay, it's a reversible reactions. So nitrogens react with hydrogens to form ammonia. Ammonia decompose to form nitrogen and hydrogens. Okay, so for reversible process, we need to find the optimum conditions, the best conditions to get most product in the shortest times. And to increase the speed of the reactions, to speed up the reactions, we use catalyst. And the catalyst that we use is iron powder. And you must remember this. Okay, you must remember the catalyst used. Now, can any of you tell me what's the catalyst used in a contact process? Do you still remember? What's the catalyst used in contact process? Vanadium 5 oxide, that's correct. Okay, vanadium 5 oxide, okay. When you write the name, you must include the 5, bracket V. Okay, vanadium 5 oxide. Okay, so this is the catalyst for contact process. And the catalyst for Haber process is iron. We use iron as a catalyst, okay. And then we have a promoter. This promoter is the aluminum oxide. Now, promoter is the substance that we use, or the chemical that we use to increase the amount of product. Catalyst is to increase the speed of the reactions. Okay, to speed up the reaction. And promoter is to increase the amount of products. So we have this promoter. Aluminum oxide, and you must remember this as well, okay. And the ratios of hydrogens to nitrogen is 3:1. I think this one should be no problems because ammonia is NH3, NH3, okay. So we have 1 nitrogens to 3 hydrogens, okay. So the ratios of hydrogen to nitrogen is 3:1. Temperature, okay, temperature 450 degrees Celsius. Again, this one is the same as the contact process. Okay, in contact process, we learned that if we use low pressure, we can get more products, but the reaction is too slow. And if we use high pressure, we can get less products, but the reaction is faster. So finally, we need to find an optimum temperature. okay, optimum temperatures to get the most products in the shortest times, okay, and the optimum temperature is 450 degrees Celsius. So in this, scientists found that under this temperature, you can get most product in the shortest time. And then for pressure, the higher the pressure, the more products produced. The higher the pressure, the more products produced. But higher pressure means higher cost. Yeah, because you need to build a very, very strong containers to withstand this high pressure. Okay, so the pressure that we use is 200 to 1000 standard atmospheric pressure. Okay, it's considered very, very high pressure. Of the higher the pressure, 1000 is the best, but the cost that incurred is very high. You must remember all these conditions. Okay, must memorize all these conditions: the catalyst, the promoter, the temperature, the pressure, the ratio. Okay,